the co-author here, outlined the biostratigraphy, the chemostratigraphy, the multi-proxy approach, I guess, to understanding the Cambrian timescale in an Australian context. I just want to kind of add a layer or two to that to introduce you to some of the environments in particular, and to some of the fossil groups that we have and that we've been dealing with to build this timescale. So what I want to do, however, is to kind of just set the scene a little bit in terms of the paleobiogeography. I've been interested in this for a long time from the point of view of East Gondwana. And when I say East Gondwana, I'm talking about essentially the Australian-Antarctic connection and its relationship to the other major continents. I'll focus in a little bit about the Flinders Ranges, where most of our data is coming from, but more and more I should say that there's a basin to the south which of course hosts the Emu Bay shale, which John Paterson will talk about in the next talk, that is also providing a lot of shelly fossil material that is a little bit older than what we find in the Arawi Basin. I'll very briefly, I could spend the whole talk going through depositional systems that occur in the Australian successions, but I'll just introduce them very briefly. And then I'll go through some of the biodiversity, introduce you to some of the trace fossils briefly at the base of the Cambrian, and a select group of a selection of Lophotrochozoans, ecdysozoans that we've been describing and reporting over the last few years. So let's set the scene. In terms of paleogeographic position, you can see Australia here is connected to Antarctica, India as part of East Gondwana, and it has a position that's pretty robustly located in the northern hemisphere in equatorial conditions. You can see on the right-hand side some kind of paleogeographic map showing from Foster et al. Looking at kind of oceanic arcs to the east of Australia. Of course, most of the modern-day Australia is, of course, not there at this time, so the frontal sea marine properties would have been around Broken Hill, for those who know. So most of the east coast have been built on from Delamerian time through the Ordovician and Silurian in particular, and it's quite a complex story. But from the point of view of the Cambrian, most of the basins are essentially running through the central part of the continent and as a series of epiric or intracratonic seas, which are sometimes interconnected, sometimes isolated, depending on what time we're looking at. But this is a tropical system, and so we get quite a lot of diversity in the forms that we've been looking at. So I want to focus in only on the basins down here to the south. I mentioned the Stansbury Basin, which is the southern one down here. You can see Kangaroo Island, doesn't seem to come out here, down to the south here. The Arawi Basin is that dumbbell-shaped basin there in South Australia. And as we go north, generally, we get younger and younger through the Cambrian. We have beautiful Ordovician sequences and so on. But really the oldest fossiliferous successions are these ones in South Australia to the south here. There are, of course, some exotic terrains to the east, and down in Tasmania they're mostly deep water basinal types of deposits. I've been attracted to the more shallow water, shelly fossil material, and that's been supplemented by the work of John Paterson and others looking at the soft-bodied Emu Bay shale. So we saw this diagram or this map earlier today when Marissa gave her talk. It's just to illustrate the extent of the basin. You can see the scale bar here, 100 kilometres. So it's 200, 300 kilometres across. The purple areas indicate the outcrop area, but there's a lot of subcrop, and thickness differs quite a bit as you go from east to west. The red dots just indicate some of the stratigraphic sections. I think we're up to about 25 stratigraphic sections from from various outcrop areas, and we of course have drill holes as well. So we've got good control pretty well, both in terms of faunas, chemostratigraphy, and we also have radiogenic dates as well. So in terms of what we see, this diagram here that John and I published in 2007, I guess illustrates the complexities of the entire system from kind of south-central platform over on your left-hand side with the succession going through, the eastern part of the platform on the right, and you can see that there's lots of wiggly lines. There's lots of unconformity-bounded successions in here, and the other key thing, of course, is there's no conformable transition from Ediacaran into the Cambrian. Everywhere it's an unconformity or a disconformity surface. Some of the key lithofacies that occur are really occurring around about the time, or essentially either side of this red line down here, which is where we start to see the incoming of diverse shelly fossil assemblages. And a range of environments, from shallow water, paralic horizons to shelf horizons, beautiful biohermal successions with microbialite, archaeocyath reefs from different parts of the platform. And just to show you, there's some beautiful examples just there. The succession that we've been looking at is in total around about 5 kilometres thick. So it's an extremely thick succession of carbonates interbedded with siliciclastics. You can see some tongues in the middle there, Neepa-Bunna siltstone, Midwurter shale. This part of the basin, this central part, is the most conformable and it's kind of also the most remote, so it's a little bit more difficult to do work there, but we've now got quite a lot of data from this area, whereas the more classic sections in the Ediacaran indeed, and into the Cambrian, are more from these more dissected sections where we get a lot more hyati. We get hard grounds. Phosphatic hard grounds are common in many kind of lagoonal deposits. We have shoal banks. We have beautiful bioclastic grainstones. So the wide range of environments here all have, of course, their own particular suites of shelly fossils associated with them. And we're starting to get a handle on this right at the moment. Beautiful outer ramp, slope deposits as well with distal turbidites, and indeed some beautiful thrombolytic microbialites here. I think these ones are about 8 feet tall or so towards the top of the section, which are really quite spectacular. Many of you would have, some of you who have been to Flinders Ranges might have visited this particular site. So that just kind of indicates that we've got a really great suite of environments to really understand not only kind of what's happening through time, but we can also put them into an ecological context as well. And we've done this in great detail for many representative sections. I'm not going to dwell on all of this. It's just to show you that in a typical stratigraphic section, we now have, thanks largely to the work of one of my former PhD students, Sarah Jacquet, great lithological information about the cycles of deposition, the depositional environments, and many of them we see a kind of an overall deepening horizon, deepening event. So we get a good handle on paleo depth and paleo depositional environments with these kind of microfacies analyses that we've got for many, not all, but many of the sections that are examples of the key environments. But I guess what I really wanted to talk to you about was some of the important or key events that we see in the succession, including trace fossils, which are quite prolific and well preserved towards the base of the section. And then as we move up into kind of more transgressive facies, we get quite a bit of shelly fossil action, as you'll see. So this diagram, I think it maybe Marissa showed it, I'm not sure, but essentially it outlines the regional stratigraphy of the Urawi Basin. And you can see at the bottom here we've got the Uratana. It's essentially unconformity bounded. So we don't really know where in the Fortunian the base of this occurs, but there are some hints. There is an acritarch assemblage towards which kind of indicates that it's down close to the boundary, but maybe not right at the boundary, which has about 25 species and quite well preserved, even though, and this has come from mainly core material, but also outcrop material. And that was published by the late Wenlong Zhang and Morgashata. Is she here? No, she's not here. So this was a great indication that the Uratana was fairly close down, but it clearly is an erosional base. We have no doubt about that. But also, we know that it's got really nice trace fossils in it. They've not really been formally described, but they've been reported and illustrated in quite a few publications. Soren et al. 1998 illustrated some and had a faunal list with their biostratigraphy, at least within the Uratana. But there are at least 15 to 20 undescribed forms in the Uratana Formation. And it's a spectacular outcrop. This is Castle Rock, and the Uratana is this bottom part here. It gets up to about 350 metres thick, and sitting on top is a sandstone with unconformity or disconformity is the Chillner Formation. And I just wanted to illustrate that this is a very siliciclastic succession. I went there to Castle Rock because Wenlong Zhang told me that there were very fine carbonates throughout this succession, and despite looking very closely, we could not find any of those. But we did find, in so doing, many very interesting fossils, including trace fossils. And again, many of these have just not been worked on in any formal sense. So there's a lot of work to be done in the Uratana, and I have to say I'm not a trace fossil worker, but there are many possibilities for projects to look at most of these horizontal traces. There's beautiful ripple marks and other sedimentological structures, and this is quite an interesting succession. So far we've got very few body fossils out of them. Here are some more traces here. Some of them will be familiar to some of you. We also have a very strange frond-like organism, and this was recently part of a thesis for one of John Paterson's honours students, and it's an Ediacaran-like frond of some type. It's not particularly well preserved, but it does occur quite abundantly over slabs. And the pen is about the right size for the scale, by the way, and it's indicating that there are some body fossils here, but there's very little shelly fossils. And of course, Soren published a paper on these in the past, and they've been looked at. We found more specimens, and so this student has looked at them, and hopefully these will be published with a bit more with the new specimens in the near future. I should also say there are sabellidated worms in this succession, but preservation is pretty poor. Now, if we go above that to the Chillner Formation, it's essentially a siliciclastic shore-face succession, but the big difference here is that it's essentially a pipe rock. It's dominated by Diplocraterian and it's churning away. Very good indication based on Gabriella and Louis' work that we're in stage 2, definitely at this stage, with the unconformity gap somewhere in between. Shelly fossils are absent from this particular part of the succession. But then as we move up, we start to get transgressional facies, including the Woodawadina dolostone, and then we come into Wirrapowie and Wilkawillana limestone. So these are shallow shelf biohermals. And we have the 3 shelly fossil zones, which Marissa talked about this morning. And the Colporina zone is based on 5 to 6 taxa, mostly tomotids, organophosphatic forms. But there are 10 to 15 other undescribed tubiform, molluscan forms that need to be dealt with. And then as we go up, you can see the Micrina ethridgi zone, which is both of these are mostly subtrilobitic, although you can see the incoming of trilobites towards the top of the Micrina zone. This is defined by about 28 well-defined, repeatable taxa, but there are another 30 or so taxa that are yet to be described, and their biostratigraphy is clearly defined. And then as we go into the R.D.C zone, which is more in kind of outer shelf, going into ramp and more distal turbidite facies, we get high diversity. 53 taxa, again, we find over and over again and quite easy to identify, but 50 or more, probably more, are undescribed. So it's a really good indication of the increase in diversity that occurs through this stage 2, stage 3 into stage 4. And by the way, I'm just talking about shelly fossils here. I'm not talking about the soft-bodied forms that occur in stage 4, which John will talk about, or he'll talk about the environment. There's another 50 or so taxa there. The tomotids are a major group in Australia. These are these organophosphatic, beautiful shelly fossils, 15 to 20 species in Gondwana. Many of them are endemic, and as we saw, Patermitra is one that's been found in North China. This is Eccentrotheca. We used to find many of the isolated sclerites of this, absolutely in their thousands, but by slightly changing the way we acid digest with a much gentler regime, we eventually found partially articulated tubes, which are really interesting. You can see the basal part of the tube is often kind of very irregular, indicating that it was attached to some hard surface, and the shape of the base was very much influenced by that hard surface. And the apertural end is usually very circular, and Christian Skovsted, my colleague, produced a very early diagram that indicates that it's some sort of fixed sessile filter feeding form. And this sort of kind of matches what we would expect for this part of the explosion. It's part of what Graham has called tube world. And Patermitra is another form. We saw that today. It's made up of these 2 sclerites, really beautiful preservation here. You can see this helmet-shaped one with a smaller S2 sclerite, so the large one's S1. And you can see this is clearly an opening for some sort of soft, we believe some sort of soft pedicle-like attachment organ. And in a few specimens, we can find these other imbricated sclerites, which are called L sclerites, forming around the aperture of the Patermitra animal, essentially extending the tube. It's still an open tube, but extending it out. So here's a reconstruction of what we think Patermitra looked like, with the S1 here, the S2 attached with some sort of organic pedicle-like structure, and the L sclerites forming an imbricated mesh around the top. I want to point out as well that they have a beautiful reticulate ornament on the surface. But if you actually cut some sections, this reticulate ornament is not just superficial, it's actually structural. And you can see the organic polygonal network quite clearly running through the entire structure of this particular organophosphatic form. And interestingly, when we cut open the brachiopod, the paterinid brachiopod Patermitra pyramidalis, it has exactly the same, in terms of scale and in terms of shape, the same polygonal network. Here's a comparison of the exteriors of Ascopasma and Patermitra. Even the tiny dots in here are the same, and they have the same structures. So we believe that these are homologous, and so that's why we think that Patermitra is a stem group brachiopod form. Dahliatia is a different type of tomotid. It's probably the most abundant fossil in South Australia, but it only occurs in South Australia and a little bit in Antarctica. We published a monograph on this that describes 7 species from East Gondwana. I've got 10,000 sclerites. That's how many we used to build the monograph, but there's many thousands or hundreds of thousands of more sclerites. And you can see the diversity here. The only difference with these guys is, rather than forming a tube, we think that they formed a much more complex cataphract external sclerotome, which built up a kind of a more interesting animal. The only reason we think this is we have a few specimens that are partially articulated. I'm nearly there. Mollusks, very briefly, are here. The macromollusks are here on the right. beautifully preserved. They're mostly steinkerns, or the macromollusks are silicified. Some new species described by Sarah Jacquet and myself. And, oh yes, this one's called Minas tirithella, for those nerds out there who like Lord of the Rings, because it looks like Minas Tirith, so I'll blame Sarah Jacquet for that one. Trilobites, of course, throughout 30 to 35 species. It's perhaps not as diverse as elsewhere, but we can use those trilobites to help subdivide the ODCI zone. And just want to finish on this group. When we started work in the Arawi, one species was known. And our work has now indicated that there's 30 to 35 species of bradorids, and probably more. And they are starting to show some really good indications that they can be used for correlation and biogeography. So for those of you who are doing work with limestones, keep your eye out for these guys, because I think they are potentially quite useful. So just to conclude, Australia, of course, is a tropical, in the Cambrian, a tropical biodiversity hotspot. And although we start off with a siliciclastic succession, which is kind of classic everywhere after a kind of a major unconformity event, we then go through the carbonate systems that produce this major diversification event. So I think, last thing, we are putting together all of this data for Flinders Ranges to become a serial site as part of UNESCO World Heritage. That will take a few years or more. Okay, thank you.